Season 2 of the Code Like an Architect series, Abstraction in Action. In the previous video, we saw how abstraction helps us reduce complexity. In this one, we will explore another very powerful ability that abstraction gives us, extensibility. And as we move forward, we will also look into reusability and reliability. So, what exactly is extensibility? To put it simply, it's the ability to build on top of existing abstractions. In the 100 real-life examples of abstraction, we already saw how abstraction gives extensibility in the real world. In this video, we will see how the same idea applies in programming. I'll demonstrate a fairly complex programming scenario. First, I will show you how developers usually approach it without using abstraction. And then I will show you how you can leverage abstraction, especially its ability to build on top of existing abstractions, and how that can actually make you a completely different kind of developer. Let's begin. Here's the scenario we need to implement. This is our admin dashboard UI, and on the UI we have a button labeled Send Data. When the user clicks on the Send Data button, the system should trigger a background job that transmits thousands of records to a B2B partner system through their API. Now let's discuss some technical details. We have an API to send data. When this API is triggered, it will start a background task and return immediately after successfully initiating the job. The job will then continue running in the background. Since we may have a large number of records to send, we will process them in batches of thousands. Each record will be passed to the partner's API. However, since the partner's API doesn't support batch operations, we will have to send the records one by one. But we will use a certain level of concurrency to improve throughput. And while sending data to the partner's API, we will also implement retry logic, up to 3 attempts in case of failure, to improve fault tolerance and reliability. Let's implement this. Here's how the implementation might look. This is the send data method. It starts a background task and returns without a wait. So we can immediately send an acknowledgement while the job keeps running in the background for a while. But there's a problem. We have some scoped objects, and the lifetime of the scope objects is bound to the request. So as soon as the request returns, those scope objects can be disposed at any time, and the background job will fail. To tackle this, we will create a new scope for the background job and move all scope dependencies into that new scope, so the request can return safely, just like we have done here. Next, we are fetching records in batches of thousands. As you can see, this part of the code handles the batching logic. For each 1,000 records, we need to send the data to the partner's endpoint, and we are doing that concurrently. In case of a failure while sending data, we will retry a maximum of 3 times. And this is the part of the code that handles the retry logic. What's your take on this code? Do you like it? Whether we like it or not, the truth is, with a few exceptions, this is how most developers usually write their code. They keep everything in a single flow, without analysis, without breakdown, without design, and without any critical thinking about the code quality. And honestly, most of us have written code like this at some point in our careers. Or at least we have been part of code bases like this, haven't we? So let's do a critical review. What's wrong with this code? Of course, everything here is written in line, inside a single method. It's complicated. Anyone who glances at this code can instantly tell that it's quite messy. Even though we have written some very useful logic here, none of it is reusable. For example, if someone needs to run a background task somewhere else, they will have to deal with the same scoped variable problem and solve it all over again. It's hard to maintain. There is a high chance that while improving the retry logic, someone might accidentally break the batching. This is a typical example of how we often find ourselves surrounded by such code, making our work harder by dealing with designs that are rigid, fragile, and immobile. But once you start truly understanding abstraction, and once you gain real practical wisdom, you begin to see how things could be written differently. Now let's put on our abstract thinking hat. Think like an architect and solve the same problem once again through abstraction. Let's begin. Rather than jumping straight into development, there is no harm in doing a bit of upfront analysis. We need to run something in the background, right? And we know that in our system, whenever we run anything in the background, we have to create a new scope and move all the existing scoped objects into that new scope. So let's create a simple abstraction that takes care of this complexity. Not just in this case, but whenever there is a need to run something in the background. Like this. This is our background executor abstraction. Next, we need batching. If you remember, we already created a batching abstraction in the previous video. So we will reuse that here. If you haven't watched that video yet, you will find the link in the description below. We also need concurrency. Here is our simple I-parallel executor abstraction. It doesn't do much yet. It simply wraps C#'s built-in concurrency support. Next, we need to call an HTTP endpoint. So let's create a reusable component for that. Like this. And since we have to call this endpoint with retry, let's also introduce a retryable executor abstraction. Like this. Finally, this is where it all comes together. Now let's see how this code works. First, we are saying run this part in the background. Handle everything that's required to run it successfully in the background. If you notice, we are delegating the responsibility to this abstraction. So whoever uses it doesn't need to know what the challenges are or how they are being solved. All they need to know is that this abstraction takes care of running the job safely and successfully in the background. Then we say do the work in the batches of thousands. The batching abstraction handles all the batching logic for us. Next, for each batch of 1000, execute in parallel with a maximum concurrency level of 100. After that, we execute this code with retry support enabled. In case of failure, it retries up to 3 times, waiting 5 seconds before each attempt. And finally, here we are calling the partner's endpoint. This code may still look a bit complicated, but not nearly as much as the earlier one. Remember, it's only a little complex because the scenario itself is complex, not because of the way we are writing the code. In fact, this code is doing its best to make even a very complex scenario look very simple. And that's possible because of abstraction. See how we are building each abstraction on top of another. Like this. Each layer is responsible for handling a specific challenge, while hiding all the underlying complexity from the layers above. Note one more thing. All of these abstractions we have created here are generic and reusable in any scenario. For example, take this retryable executor abstraction. It's not limited to just this use case. You can use it anywhere you need to perform retries. The same goes for the HTTP service or the I-parallel executor. You can reuse them anywhere, even in other projects. Take the batch processor for example. We are already reusing it from the previous video. Now look at the background executor. Think about the scoped variables it manages. We carefully analyzed that challenge, identified the problem, did our research, found the right solution, and implemented it carefully. Once we did that, we wrapped it all inside a simple abstraction. Now anyone working on this project can use it without going through all those challenges again. We faced those challenges once and solved them for everyone. And as long as it keeps working, no one even needs to know those details. They can simply use it and move on with their work. This wasn't the case earlier when the entire implementation was written in line. It was not only difficult to understand, but also impossible to reuse. Now with abstraction, our code has become much simpler. And along the way, we have also created a set of generic reusable components as a natural byproduct that we can now reuse in a wide range of scenarios. That's how abstraction elevates your programming. And it's one of the most important concepts you must master to code like an architect. Let's keep exploring. Suppose we want to change the batch size from 1000 to 10,000. Here's how we can do that. Suppose we want to retry 5 times instead of 3. It only takes a minute. What if later on we want to use exponential backoff retries instead of a fixed delay? We will simply write a new implementation, register it in DI, and we are done. without changing a single line of client code. Now imagine doing this with our previous approach. It wouldn't have been that easy. There would have been a risk of breaking other parts because everything was tightly coupled. What if we later discover an issue in our concurrent execution? Something isn't working as expected. Without abstraction, we would have to fix it everywhere the code was copied. But with abstraction, we can simply apply the fix in one place or even switch to a new implementation if needed. In addition, if you think about it carefully, abstraction also improves reliability, which is a very important quality attribute in programming. Let me explain. Suppose you build these abstractions and start using them. What happens next? You might run into bugs. For example, the batching abstraction stops the entire execution if any single batch fails. The exponential backoff retry isn't calculating delays correctly. There are a few concurrency issues being reported. Plus, you discover several null checks and other validations are missing. You fix all of those. 6 months later, we hit another issue. After investigation, we find the parallel executor works fine in normal situations. But on exceptions, it fails silently, leaving no trace in the logs. You fix that. 2 years later, it turns out the background executor works fine, but if the server restarts due to deployment, a scale down event, or anything similar, the background task is lost. So you add support to resume after restarts. Now it's a fairly sophisticated implementation. Now all of these abstractions have been running in production for years, used in many places across the codebase and even in a few other projects as well. Now, when you're writing code for a new feature, you can easily reuse all of these abstractions, right? That gives you reusability. But not just reusability. If you think about it carefully, it also gives you reliability. These abstractions and the implementations behind them have been running in production for years. It's well tested, trusted, and used in countless places across real systems, sometimes even across projects. So, when you use it in your own scenario, there's a strong chance you won't face any issues at all. That's the beauty of it. You don't just get reusability, you also inherit reliability. And that doesn't just save development time, it also raises the overall quality of your code and your entire product. In the next video, we will continue exploring more benefits of abstraction, generalization, and swappability. Keep watching.